So today we're going to be talking about squares and square roots, and we're going to first start with squares. So in order to find the square of a number, you must multiply the number times itself. This means that you are taking it to the second power. And that's just saying the exponent. So let's say we have 2 squared. This will be the second power, or the exponent. So to find the square root of a number, you need to multiply it. You must multiply the number times itself. So this is just saying 2 times 2. You're taking 2 to the power of 2, so that means 2 of itself. So 2 times 2, or 2 to the power of 2, will equal 4. And now I also want you to remember this 2 was our base. So this is the base of our number. So 2 to the power, or exponent, of 2. We call the squares of whole number perfect squares. And that's because if we think of a square, so let's say this is 2 squared, like we've been doing over here. There's 2 boxes on this side, so 2, and 2 boxes on this side. And it's going to make a perfect square. It's not going to be a rectangle. It's exactly the same size on both sides, so you're multiplying the same number times itself. So let's look at our first 20 perfect squares, and you should be practicing these at home so they're very easy. So we'll think of 1 squared. So that's just saying 1 times 1. 1 times 1 is 1. 2 squared is just like saying 2 times 2. Well, let's think. What's 2 times 2? 4. 3 squared would just be like 3 times 3. 3 squared, or 3 times 3, equals 9. 4 squared would just be like 4 times 4. And 4 times 4, or 4 squared, is 16. Now, when you get down to these trickier ones that are bigger and you don't use as often, it's important to remember them, but it's also important to know that you can just multiply them up and down if you don't have a calculator. So think of what 12 squared is. It's 12 times 12, but let's multiply it. So 2 times 2 is 4. 2 times 1 is 2. Add that 0 in. 1 times 2 is 2. 1 times 1 is 1. Let's add them up. 4 plus 0 is 4. 2 plus 2 is 4. And 1. So our 12 squared is 144. So you can solve for the square root, when a number is squared, even if you do not know it off the top of your head. So now I want you to go ahead and do the rest of these problems on this page on your own. If you are having any trouble or have any questions, please raise your hand. Please pause the video. Okay, now we're going to go over your answers. We have 5 squared. 5 squared is 25, so just like 5 times 5. 6 squared is 36. 7 squared is 49, 7 times 7. 8 squared is 64, 8 times 8. 9 squared, which is just like 9 times 9, is 81. 10 squared is 100. 11 squared is just like 11 times 11, which is 121. 13 squared, which is just like 13 times 13, is 169. 14 squared is 196. 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And 20 squared is 400. Okay, now you're going to turn the page and we're going to be talking about square roots. So square roots are the opposite of squaring a number. So instead of knowing what times what equals, and you're going to find the answer, you're going to have the answer and figure out what times itself will equal that. So the square root of a number is one of its 2 equal roots. So what times what is going to give us that number under our radical? So to find the square root, so here's our radical, or root, you must find which number times itself is equal to the number under the radical. So this thing right here is our radical. Whatever number is under it, so let's say 4 is under our radical, we need to figure out what times itself will get us to 4. So we have our tree over here. We're going to put our radical on our 4, so the square root of 4 under it. We need to figure out what times what is going to get us to 4. So let's think. 1 times 1 is 1. 2 times 2 is 4. So we know our roots will be 2 times 2. So our roots get us to that number under the radical. So this is our answer. So now we're going to look at our first question. So number 1, the square root of 16. So we need to figure out our 2 roots for 16. So what times itself will get us to 16? And if we don't know, we can think of each number and go in order. So like we did for the square root of 4, we did 1 times 1, that's 1. 2 times 2, 4, so not there yet. 3 times 3 is 9, so we're not there yet. 4 times 4 is 16. Well, the square root of 16 would be 4 times 4. So the square root of 16 would be 4. Now we can also draw this number as a model, showing that on each side it'll be a perfect square. So 1, 2, 3, 4, 1, 2, 3, 4. And inside these shaded boxes will be 16 little boxes. So 4 on this side, 4 on this side. And in here we'll have 16 total. Over here we have the square root of 100. What times itself will get us to 100? Well, we did 4 times 4. But we need to be a lot bigger. And we know it ends in a 0, so it could be a 5 or it could be a 10. So, well, let's think 10 times 10. Ooh, the square root, or 10 times 10 equals 100. So the square root of 100 is 10. Now to draw this as a model, we can do it the same way as we did the last one. And we're going to do 10 across, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10 down, 1, 2, 4, 5, 6, 7, 8, 9, 10. And then we'll shade in the entire middle of our model. Now on this side, we know we have 10. And on this side we have 10. We will have a square, and our inside of our square will be what we have found the square root of. And there'll be 100 little boxes inside this whole little model. Now let's look at the square root of 25. What times itself will get us to 25? So we know 4 times 4 is 16, 5 times 5. Well, 5 times 5 is 25. So the square root of 25 is just 5. Now I want you to draw the model for this one. Think about what the square root is and how big each side of our square is going to be. Okay, so we drew and colored our square, and we need to think about how big each side is going to be. So what times itself will get us to 25? 5 times 5. So in here there'll be 25 little boxes. So if you count them all up, there'll be 25. And that's how we show that 5 times 5 is 25. Now we're going to do the square root of 144. What times itself will get us to 144? So we knew 10 times 10 was 100, so we know it has to be bigger than 10. So let's keep going. 11 times 11 would be 121. 12 times 12. 12 times 12 gets us 144, so the square root of 144 is 12. Now think of the square root of 9. I want you to pause the video and hit play when you know what the square root of 9 is. Square root of 9 is 3. 3 times 3 will get you to 9. I want you to go ahead and do 6 through 12 on your own. If you do not understand what you're doing right now, please go ahead and raise your hand. I'm here to help you. So go ahead and pause the video. Okay, so let's solve this. The square root of 49 is what times itself will get us to 49. So the square root of 49 is 7. The square root of 121 is 11. Square root of 64 is 8. 8 times 8 will get you to 64. Square root of 81 is 9. 9 times 9 will get you to 81. Square root of 256 is 16. And if you don't know the answer to this question right away, so if you can't think of the square root of 256, you can also just do trial and error. So, for example, for number 4, we did 144. We looked at what 11 times 11 was, what 12 times 12 was to get to 144. So for 256, we can think of what 14 times 14 is. Are we there yet? 15 times 15 is 225. Are we there yet? No, we need to get to 256. So what's 16 times 16? 256. So just keep trying to get to that answer. And if you pass it, then that means that you can't take the square root of it. So the square root of 4 is 2, and then the square root of 36 is 6. So 6 times 6 will get you to 36. Okay, now for this section, it says find each square. So that means we're going to have to square each one of these numbers to take it to the power of 2, and then solve. So 9 squared is equal to 9 times 9. 9 times 9 is 81. 10 squared equals 10 times 10. And I want you to go ahead from this point and solve 10 times 10. Hit play when you're ready. Go ahead and pause. 10 times 10 is 100. I want you to do 15 and 16 on your own. When you know your answers, please go ahead and hit play. Pause the video. Okay, 17 squared equals 17 times 17 equals 289. 6 squared equals 6 times 6, and 6 times 6 is 36. Okie dokie. So for this section, we are going to be looking at some integers and deciding if we can take the square root of it or not. And if we can't, we're going to be putting it in our no column. So that means we'll be finding the two consecutive whole numbers it falls between. So that would be whenever you take the square root, but we'll get into that once we get there. So let's look at our first number. So we need to find the square root of 1. Square root, can we multiply anything times itself to get to 1? So let's start. Well, 1 times 1 equals 1. So the square root of, so yes, we can take the square root. And the square root of 1 will be 1. Okay, now we need to look at the square root of 7. Can we do this? Can anything times itself be 7? So let's think of 2 times 2. Well, 2 times 2, the square root is, 2 times 2 is 4, so the square root of 4 will get us to 2. So that's below 7. Let's think of what the square root, or 2 times 2, 3 times 3 would be. Well, 3 times 3, this would be 9. So the square root of 9 will get us to 3. So the two consecutive whole numbers it falls between, because we can't get to 7, so we need to figure out the two whole numbers it falls between, would be 2 and 3. And that's because we can take the square root of 4, and that's 2. We can take the square root of 9, and that's 3. So we need to figure out the two whole numbers it falls between when we are able to take the square root. So let's do the next one, the square root of 9. So what times itself will get us to 9? Well, we already did it. 3 times 3 gets us to 9. And when we take the square root of 9, we get 3. Now let's do the square root of 12. Are we able to take the square root of 12? So we know 3 times 3 is 9, so let's keep going. 4 times 4. That'll get us 16. So we knew 9, so we knew 3 times 3 got us 9, and we knew 4 times 4 got us to 16, but there's no square root of 12 in there, right? So we need to figure out the two consecutive integers it would fall between. What are two consecutive whole numbers it would fall between? So where is it falling between? We have 3 and 4. So it's going to fall between 3 and 4. Now I want you to go ahead and find the square root of 25. See if it's yes, a square root, or no, and you're going to figure out the two consecutive whole numbers it falls between. Go ahead and pause the video. Okay, so the square root of 25. What times itself will get us to 25? Well, 4 times 4, 5 times 5. 5 times 5 is 25, so yes, it will be a square root, and it's 5. Now we have 33. We need to figure out if we can take the square root of 33. I want you to go ahead and try. Think about what is around it. Think about what times itself will get us near 33 if it's not a square root. Go ahead and pause the video. Okay, so let's see if you got this right. So we have to think about what times itself will get us to 33. And I know 4 times 4 is 16, so we're a little close. We knew 5 times 5 will get us to 25. So let's think 6 times 6. We'll keep going in order. 6 times 6. Oh well, 6 times 6 is 36. So we already passed 33, so we know we can't take the square root of it. So what's it between? What consecutive whole numbers does it fall between? So when we take the square root of a number and we're able to do that, what are those numbers that we're getting? So we had 5 and 6. Now I want you to do the square root of 36 on your own. See if you are able to do it, yes or no. You need to find the two consecutive whole numbers it falls between. Pause the video. Square root of 36, you can do that, and it is 6. If you have any questions about this section, please raise your hand now and ask me. Now we're going to look at the next page, and it says circle the square roots of perfect squares, then evaluate. So first we're going to go through and circle the perfect squares. I want you to think about what times itself is going to get us to each of those numbers. So think about the number 32. Is there anything times itself that'll get us to 32? So well, we know 5 times 5 is 25. So then 6 times 6 is 6 times 6 is 36. So we go from 5 to 6, so there's nothing between, so we know 32 can't be a perfect square. 64. So what times itself could get us to 64? Well, we know 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. So yes, that would be a perfect square. So 324. Think about what times what could get us to 324. It's a pretty big number, so let's start at, let's say, 15. So 15 times 15. And I can't always do this in my head, and I don't remember the perfect squares. So 15 times 15, 5 times 5 is, 25, carry. 1 is 5 plus 2 is 7, add that 0. 1 times 5 is 5, 1 times 1, add them up. So 5, 2, so 225, so kind of close. So let's go to 17 times 17. 7 times 7 is 49, 7 times 1 is 7. Plus 4 is 11. 1 times 7 is 7. 1 times 1, 9, 8, 2. So we're getting closer. Let's do 18 times 18. Times 8 is 4. 8. 1 times 8 is 8. 1 times 1 is 1. We have 4, 8 plus 4 would be 12, and then 1 plus 1 plus 1 is 3. So 324. So yes, 324 would be a perfect square. Now I want you to go ahead and see if you can decide if the square root of 101 is a perfect square, the square root of 196 is a perfect square, the square root of 44, square root of 121, and the square root of 361. Circle your perfect squares, and then go ahead and hit play. Please pause the video. Okay, so we have 101. So we know 10 times 10 is 100. So we would look at 11 times 11. 11 times 11 is 121, so that's not a perfect square. We have 196. So to find the square root of 196, we can think of what times itself will get us to 196. So we know 12 times 12 is 144. So 13 times 13 is 169. So we're not there to 196 yet. So 14 times 14 is 196. So yes, 196 is going to be a perfect square. So now we have 44. We need to think about what times what could get us to 44. Well, we have 6 times 6 is 36, 7 times 7 is 49, so we passed 44, so that is not a perfect square. 121, what times itself could get us to 121? So we know 10 times 10 is 100. 11 times 11 is 121, so yes, that would be a perfect square. And then 361, what times 361 could get us, or what times itself could get us to 361? So we know it's going to be a high number. And we know 324 was multiplied 18 times 18, so let's try 19 times 19, and that is going to get us to 361. So now it says evaluate, so we need to figure out what would be the square root of 64. So I want you to go through and find the square root of each of these numbers and write it below. So for example, the square root of 64 would be 8. I want you to do it for the 4 that we have circled. Hit play when you are done. Go ahead and pause the video. Okay, so the square root of 324 is 18. The square root of 196 is 14. The square root of 121 is 11, and the square root of 361 is 19. Okay, so here it says which model represents this expression. So the square root of 400. So what times itself will get us to 400? And I always think if the number ends in a 0, it could either be multiplied by a number ending in a 5 or a 10. So we know 10 times 10 is 100. Well, 20 times 20, and sometimes I can't always do this stuff in my head, so let's think. 20 times 20, 0, and then 0, 2 times 2 is 400. So we know it would be 20 times 20, so let's look at our models. And what I always like to do is cancel out models that don't make sense. And we know we have to have a perfect square, so both of our sides of our square are going to be the same size. So let's look at A. So this one says 20 times 20, so this one could be our answer. B says 25 and 16. Well, those two sides aren't the same, so this couldn't be our answer. C says 20 and 2. Those two sides aren't the same, so they won't be a perfect square. 40 and 10. Those two sides aren't the same size, so they won't be the same. The only thing we're left with is 20 times 20, and we knew 20 times 20 equals 400, so our answer is A. So today we learned about squares and square roots. If you have any questions about anything you've learned in this video, please raise your hand and ask me.